Have you ever noticed that we write pH like this and not like this? This is how we write a PhD, if you have a PhD in something. But this is how we write pH, as in like the acid bases that we've just done. Right? So, why is it a capital H? Ever? The hydrogen. What makes an acid according to Arrhenius? The H pluses, right? The hydrogen ions. That makes the acid, the H plus. So, if I have a flask that has a lot of H pluses in it, is my pH going to be 1, 6, or 14? A lot of H pluses, not a trick question. Junior high. Well, not really junior high. 1. A lot of H pluses, very acidic, lots of acid, so therefore pH of 1. So what would a pH of 6 look like then? Not very many. Let's just draw 1 for the sake of it. So if I have a lot of H pluses, I have a low pH. This would be called a strong acid. And if I have just a little bit of H pluses, it would be a weak acid, and I would have a pH of a weak acid. Everybody get the picture diagram and understand how that looks like in a solution, right? We've been talking about zoom, zoom, zoom in. What would we see? Zoom, zoom, zoom in. I'd see a lot of H pluses. I'd also see the Cl minuses, but I'm not really talking about those right now. And here, I'm just going to zoom in and see very few H pluses, making it a weak acid. Everybody get that? Okay. So, if I'm zooming in and seeing a bunch of circles in a liter of water, isn't that concentration? Yes? And have you ever seen a concentration of an acid somewhere on a bottle, like a 1 mole per liter HCl solution? So yeah. So if I could say I have a 1 mole per liter of HCl solution, in fact I'm just going to make it a 0.2 mole per liter HCl solution just to make our calculators a little easier. Okay. If I have a 0.2 mole per liter HCl solution, how many H plus, what concentration of H pluses have I got in there? Well, for this we'd have to go, well, my HCl is going to combine with that water and it's going to make H3O pluses and Cl minuses. Everybody with me? And if I have 0.2 moles per liter of this, what do I have of this? 1 to 1 to 1, so 0.2 to 0.2 to 0.2, just like we did a month ago. Concentration of ions. You with me? So, what we're going to learn today is how can I get from that number from last month to an actual pH number. Okay? And there's a formula that we use. Now, it's not a very difficult formula, except for it doesn't really align itself with the math curriculum. Okay? So, pH, this is the formula. In order to calculate the pH, I'm going to take -1, or I don't really need the 1 in there, do I? And I'm going to take the log, and already you're going, huh? I know, of the H3O plus. Okay? Now, what is log? Log is a function. I'm not going to go into very much detail about what log is. I'm going to leave that for the Math 30 teachers. But I am going to say to you it's a function, like multiplication, division, addition, subtraction are all functions. Log is another function. Okay? For us in Chem 30, we have a calculator. And if it was multiplication, I would just hit the multiplication button to multiply things. So I'm going to hit the log button. Nice. Okay? So, -1 log of 0.2 in my example. Right? So, see the log button? It's beside your number 7. Everybody found it? Beside the 7 is a log button. So you're going to hit the log button, and you're going to put in 0.2. You can close the bracket if you want to. And you're going to hit enter. But it's negative. So I'm just going to take the negative of that number. So I'm going to take positive of that number. Or if you prefer, because you want to do things a bit more literally and you don't want to dump that step because you're not very math strong, hit the negative then first. Then log. Then 0.2. Then enter. Either way you get positive 0.699. Okay, how many significant digits have I got? Just one, so I'm going to write down that my pH is 0.7. Is that a strong acid? pH of 0.7? You bet. Is HCl a strong acid? You bet.
It's messed up.
Who is this messed up? I don't really know how to do this the long way, so I'm going to do it the short way, okay? It means that you've set your... Oh, no. Look. Oops. Okay, so your answer says E -1 on the end there, which means it's... Right? Okay. Any other problems with anybody else's calculator? Did everybody get 0.7? I need everybody to play along and punch in the numbers so that we are comfortable with these weird buttons now. Everybody get 0.7? Okay. Let's try again. What would the pH be if I had a solution of H2SO4 and it is a, oh, that might be a little bit too hard actually. Let's stick with HCl, and I'm going to have a 0.0035 mole per liter solution of HCl. So therefore my pH equals? Negative log 0.00. Everybody, play along. And bracket. And so punch in if you like to. You can put the negative in first. Negative log 0.0035. Did you get a pH of 2.5? Yes? Everybody with me? Questions so far? Okay. So, I just happened to see it over there. Any questions? Did you get it? Okay, so now, if this was a multiplication and I wanted to solve for my H plus concentration, because I can see my pH of this is 6 because I put my pH meter in it or put my universal indicator paper in it and I saw a pH of 6. But I'd like to know what is the concentration of H plus floating around inside. So if I have this, and I want to find out about this, if this is my unknown, if this is my X, wouldn't it be great to divide both sides by log? Right? Except for it's not multiplication. I said it's its own function. And we have to do the opposite function of it. If it was multiplication, I would do the opposite, which is division. If it was addition, I would do the opposite, which is subtraction. Right? It's log. I need to do the opposite of log. Oh my god, I don't know what the opposite of log is. The calculator tells you. Look at the second log. Do you see on the log button? Do you see the second of that is 10 to the power of? That's the opposite of log. Okay? So, in order to reverse this, first of all, I have this formula then. The reverse of this formula is if I want to find out what H3O plus is, I'm going to take 10 to the power of, now I have this -1 still, so it's negative pH. So that's my second formula. So one formula, two formulas today so far. 10 to the power of negative pH. Everybody okay with that so far? So if I had a pH of 6, and I want to find out what the H3O plus concentration is, 10 to the power of? Negative 6. Which? 0.12345 6. Oh, I mean 1. Because your answer is just going to say 1e negative 6, doesn't it?
Yeah.
Right? So 1e negative 6, because that's what that is. But that's what that is in the decimal place, just so you can see it. So that's the decimal place moles per liter. Does that make sense? Now that's easy to do because it's a whole number. But what if my pH was negative 6.2? Okay, so my pH is 6.2. Well, now my concentration is equal to,
6.3.
right, 1 times 10 to the power of negative 6.2, I would hope, moles per liter. No, what is it?
Negative 7.
6.3? 6.3 times 10 to the power of
Negative 7.
negative 7 moles per liter, which is approximately 1 times 10 to the power of negative 6, like it's not far off. Okay? Does that make sense? Everybody okay with those two? Everybody okay with those buttons? Okay, so nice and easy so far, other than this foreign button. Here's the new concept. pH equals the scale, right? We talked about the scale. We said that 7 is neutral, and that below 7 is an acid. So 6, 5, 4, 3, 2, 1, 0, strong acids, right? And 8, 9, 10, 11, 12, 13, 14, strong base. Okay? There's actually existing a pOH scale. So if this is pH, I have a pOH scale as well for bases, really, right? And it's the exact opposite. So pOH, 14, 13, 12, 11, 10, 9, 8, 7, still on neutral. 6, 5, 4, 3, 2, 1, 0. And notice the total of them is always 14. 14 and 0, 14, 13 and 1, 14. Okay? So your pH and your pOH, because they're exact opposite, equal 14. And if I have a 14, it's still a strong acid. And if I have a 0, it's now a strong base. Did you get that concept? So we've got a third formula and the understanding that it's the exact opposite. So pH of 1, strong acid or strong base? Junior high pH, strong acid. Okay? pH of pOH of 1 will be a strong base, the opposite. Everybody okay with that? Okay? Okay. So that's your third formula. Now, that means that if I have some sodium hydroxide solution, everybody okay with sodium hydroxide being a base? And it's a 0.9 mole per liter solution of sodium hydroxide. How much OH minus have I got? What concentration of OH minus?
0.9.
Good, because this is an Na plus and this is an OH minus and it's a 1 to 1 to 1, so it's a 0.9 to 0.9 to 0.9. Okay, so I have a concentration of OH minus. See that? I can calculate the pOH for it because it's the same formula, just different. Sure. So pOH equals negative log concentration of, if pH equals negative log H plus, then pOH equals negative log OH. OH. Remember H3O plus is just H plus, right? It's the same thing, just piggybacking right on water. Did that in our warm up. So H plus, OH. So once you've memorized this formula, it's the same thing. It's not actually like a new formula, it's just a twist. Okay, so it's like we only have to memorize one thing really, and then just change it a bit. Okay, so 1, 2, 3, I'm going to call this my fourth formula, or I can call it 1B. Right? Just like question 1, just for the base. 1A for the acid, 1B for the base. Okay, so pOH was right? And so negative log of 0.9 equals what? Well, let's make sure we can still do it on our calculators. Negative log 0.9 equals 0.046. Rounding. Oh, I only have one significant bit, so that's 5. Everybody okay? pOH being really low means it's a very strong base. It's the opposite. Could we calculate the pH from this? Did we calculate the pH? Oh, so I could go over here and use this formula. If pH and pOH equal 14, then my pH plus this 0.05 should equal 14, right? So what's the pH equal then? 13.95. Is that a strong base? And are we talking about a strong base? So that makes sense. Yeah? And if we found our pH, could we find our H plus concentration? Times 10 to the power of negative 13.95. Yes? So this would be 10 to the power of, or second log, negative 13.95, and I get 1.1 times 10 to the power of negative 14. Everybody okay with that? Moles per liter, because it's the concentration of H pluses. Everybody okay with the math? Put your hand up if you're not, because I'm about to move on to a big point here. Anybody want me to go over that math again? So we said, here's some NaOH. It has a 1:1:1 ratio, so it's a 0.9 to 0.9. We've got this pOH formula, so we can plug that concentration into here, and we get the pOH of 0.05, which, okay, is a new scale that we don't really like, because it's the opposite. It's like opposite day. Don't like opposite day. So I'm going to change it into something I know something about, like pH. And pH of 13.95, that sits a bit better for us. We kind of get that in terms of it being a strong base. We like that. And we can use that, we can plug that into a new formula here, where we can find the H plus concentration, which is teeny, teeny, tiny. Okay? Wait a minute. Where'd the H pluses come from? Are there H pluses in here? No, right? So scientists are like, what? Whoa, what happened? What happened? Where did those H pluses? Mathematically, we've got H pluses. Mathematically, I need something to make up for that little extra bit that's not quite 14 yet. So where did the H pluses come from? And then they discovered that a tiny bit of water will decompose into H pluses and OH minuses. So where did the teeny tiny bit of H pluses come from? The water. Okay? Get that, everybody? So a tiny bit of water dissociates into these two things. And then from this, and this equilibrium, remember forward and reverse are equal, you come up with this special number, which is 1 times 10 to the power of negative 14 equals your concentration of your H plus times your concentration of your OH minus. Huh. I'm going to call this 3B. My equation. I know I've missed 2b so far, I know. So this formula here, where I have 1 times 10 to the power of negative 14, is quite similar to this, 14. And these pHs and POHs are quite similar to that H plus on that OH minus. These are multiplied, these are added. Be careful of that when you're doing your work. These are multiplied, these are added. Okay? And so let's take this number here. And let's plug that number into here. And 1 times 10 to the power of 14 equals 1 times 10 to the power of negative 14. In fact, actually, you know what I need to do? I need to go back. Remember that was 0.049 lol, whatever it was? I need to have all those numbers in my calculator. So let's go back. Negative log 0.9 equals a lot of decimals. That number here is this number here. So 14 minus that whole big number is 13.95 and a bunch of other decimals. That over here is 10 to the power of, oops, not that button. That one, negative my answer, and I get 1.1111 times 10 to the power of negative 14. Okay, I've gone back to this but put all the decimals in. So I'm going to put that in here, times my OH minus, equals still 1 times 10 to the power of negative 14, equals that number, times my OH minus concentration. So 1 times 10 to the power of negative 14, and for this I'm using the E button. We've talked about the E button and how it's better for our calculators. So 1E negative 14 divided by that POH concentration, and I better get 0.9. Booyah. Why had I better got, why was I hoping to get 0.9? Because that's what I started with. That was my concentration. Okay.
What is the E button?
You know how when you get an answer and it says E negative 3?
Yeah.
Well, okay, so I want to do the same thing. Because then the calculator does this as one number, not times 10, which actually might only divide the times 10 bit.
How do you
So E is second, see above the 7 you've got a comma, and you've got those 2 E's, that's what you want. So you want 1 second comma, so now it should say E, negative 14 divided by 1.111 second comma, so I've got my E again, negative 14, or divided by your answer if you have your answer in there. Enter 0.9. Sabrina, what's the matter? Tell me so I can help.
That last part, like, I just don't know.
What? You got lost?
Yeah.
Okay. So, have you written everything down? So I can erase it? Okay. So this part's not important, this part's not important, this part's not important. We understand that pH is opposite scale. My point at the very end there was that all these formulas are connected. They're just connected. That's my point. So if I started here and I went through that formula, that formula, that formula, that formula, that formula, I should end up back here because they're all connected. That's my point. If I started with a concentration of 0.09, no matter what I did to it in all these formulas, if I go and find the concentration of OH minus again, I better end up with 0.9. I haven't changed anything. That was the one point. The second point is you have both OH minuses and H pluses because of water, which is unusual for us. If I had asked you at the very beginning of the lesson how many H pluses in there, you would have said none. And now I'm saying, there are some, and they're caused by water. Okay, so that's a new lesson too, and the POH and the pH scale being opposite days for us. Okay, so I have this formula, 1A, pH equals negative log concentration of hydrogen. I have this formula, 1B, POH equals negative log OH concentration. I have this formula, H plus concentration equals 10 to the power of negative pH, which was the opposite of each other, right? And I have a 2B, which would be that the OH minus concentration, see I'm going to follow the same pattern here, equals 10 to the power of negative POH. See how this formula and that formula are the same but different. Oh, shoot. Everybody okay with formulas 1A and 1B? Everybody okay with formula 2A and 2B? Okay? And then we have these, formula 3 helps us go between the H pluses and the OH minuses. So I've got this POH formula, and I've got this concentration of H and concentration of OH minus. So if I want to go from this to this, I would use one of these. Or from this to this, I would use this. Okay? Now in every other chem questions, math stuff that you've done, you've kind of had to do exactly like the person beside you. If the person beside you is taking the mass divided by the molar mass, and then taking that answer and divided it by the volume, you've had to do exactly the same thing as them in order to get the right answer, right? Here it's different. I could follow quite a few of these different paths and I would end up with the right answer. So if the person beside you is following a different path than you, it's okay. But you both should end up with the same answer. Okay? So, for example, and I'm only going to give one example, and then you guys are going to try to do it on your own. We'll go back to our lovely HCl that we started with. We're going to go back to a 0, in fact I'm just going to make it a little bit more dilute, so a 0.02 mole per liter solution. And I'd like to know what is, I asked you what the pH was at the beginning of the class. I'm going to ask you what is the POH of this. Okay? Who would like to take a start? Which one of these formulas? Pardon? 1B? 1B. 1B? POH equals negative log OH minus concentration. Where do I get my OH minus concentration from? Can I get it yet? No, not quite yet. Could I find it? How?
1A and then 2B.
Okay, that's another formula. You want to use 1A first?
Yeah.
Okay, so it's another pathway we could do, completely different than Sabrina's pathway, but I could have used your pathway, Sabrina. So we could take this, okay, what do we have, you guys? What are we given? Concentration of what? HCl. Can we make that a use of any of this stuff? Not only do we have the concentration of HCl, we actually have the concentration of H pluses in the HCl. What's the concentration of H pluses? 0.02, because it's a 1:1:1 ratio, without even writing it down. So it's a 0.02 to 0.02. Everybody okay with that? So I'm going to rub these formulas out because it's just looking a bit messy and I'm not liking it. So what if I used, with that concentration, could I solve for pH?
Yeah.
Yes? Okay, let's do that. pH equals what? Negative log concentration of H plus, which is in this case negative log 0.02. Okay, punch it in and tell me what you get.
1.7.
1.7. So how do I get POH from that?
subtract 14.
Right, 14 minus 1.7. Because POH plus pH equals 14. So 14 minus that, which equals 12.3. Have I answered the question?
Yeah.
Answer the question. What is POH? POH is 12.3. Okay? Sabrina, you wanted to use this cup, this one, right?
Yeah.
In order to do that, I'd have to use this first. Do I have this? Yeah. So my OH minus concentration times 0.02 would equal 1 times 10 to the power negative 14. So do that first, Sabrina. Right, 1e negative 14 divided by 0.02 equals 5 times 10 to the power of negative 13. Did everybody get that? This is the concentration of OH minus. So I'm going to put that in there. Negative log of Sabrina's answer. And Sabrina, what do you get?
Sorry, I'm still writing this stuff down.
12.3. 12.3. So do you see how Sabrina's pathway and Janae's pathway, same answer, but very different formulas. Okay? Okay, so in your snap books, on page 166, question 6, 7, 8, 9, 10, but of course we're going to need to do some of this on Monday. All right?